So let's now move on to our next topic. We're going to talk a little bit about the display we're using. And I'm going to pop back on my camera. And actually, let's do it this way. I'm going to zoom in here for a moment. And so you've seen this a few times. I'm going back to our HackKit Pro version here. And it's a little bit washed out. We've got our display here. This is our TFT. There we go. Our TFT SPI. This is an ST7789, 240 by 240 pixel, 16-bit, actually up to 18-bit color display. And this is a really cool, really beautiful, crisp display. For those of you that have the Hack Kit, you do have this one in that kit, also available from a lot of retailers. And this is a really fun way to give some visual feedback to your projects. But display is only as useful as the API. So we're going to dive in and talk a bit about what we now call micrographics. And it was our graphics library. And it's a graphics API specifically designed, again, for IoT devices. And what's really fun about this is not only is it a nice, tidy API, but again, thinking about usability, but we've thought about how we can make a consistent API surface regardless of the type of displays you're using. So for example, imagine you're doing something like this. This is an e-paper display. And I love this. I actually pull back. Notice no wires, no batteries. This is not powered right now, but that display holds its state. Love these low power e-ink displays. Now this here, this is basically a 3-color display. It's got red, black, and then just the default white. So that's going to be a little bit different than controlling a full 16-bit or higher color display. And now if you also appear over my shoulder, I'm going to scooch over a little bit. This is our fun one. So this is the display, and this is the Max 7219 controller, and I can get a close-up of that in a moment. That's basically just an array of LEDs. There are 4 LED arrays that are 8 by 8. So that display there is actually using 8 by 32 pixels. Very, very different than something that's using 240 by 240 pixels. So we had to think long and hard about how we could expose an API that's going to let us control everything from complex, high-res, high-density displays to very, very basic arrays of pixels. So let's talk a little bit about micrographics. And Jorge, I might lean on you for some demos here as well. But
of course.
Let's get my screen up and let's look at some code. So back to our Meadow HackKit code. And in our code, we have a display controller. And we've looked at other things we've instantiated for our hardware. And again, we're going to see similar patterns. We're going to use that device class again. But I love seeing this over and over again. So back to our nice driver patterns. So in this case here, we're going to have an ST7789 object that's going to represent the display. And we have that. Now, I've got the code here with local project references. So it's actually referencing the code in Meadow Foundation. But you would do that by pulling in the SCF, the TFT SPI NuGet package that will give you access to drivers for a number of these color displays. Right below, we also have something else very important. This is our graphics library. This is actually, we're calling it micrographics, and you might see some API changes in the future as we're towards version 1.0. But today, the class name is a graphics library. And these are the two things together that are going to allow us to control the display and do some really interesting things. I'm also going to point out one more thing here. We're going to pass our menu for a moment and come back to that. And that's this buffer class. So new in beta 6 are these buffer objects. And these are going to allow us to store really display data of various forms. And I talk a little more about that, but I'm pointed out because we're going to make use of this as we update our display. So first things first, how the heck do we use our displays? So similar to what we saw before, and Jorge, I love seeing consistency. So we need to instantiate our display. We new up the object. Now this display is a little bit more complex than some of our other peripheral sensors. There's more connections to it. SPI, in this case, it's a 4-wire. Yes, it's 4 on mine, sometimes 5-wire to control these SPI displays. And so we also have a lot of flexibility on how we communicate with them. And SPI is actually, it's a higher speed bus than I2C. We can control that clock speed. We're doing that here. So we set up our configuration. We can, for our SPI, we instantiate the bus. And then again, we pass in that configuration. And this is interesting So unlike I2C, we can chain a whole bunch of devices onto that bus. For SPI, we can do it, but there is some SPI specific configuration like that speed and that mode. And so we can put more than one thing on that bus, but these settings need to be compatible. And so we're gonna set that up here and then pass it in when we instantiate our device. And what's fun here is notice this display color mode, and actually the width and height as well. So we're putting the parameters for our display. This particular controller, you can get various resolutions of those displays. 240 by 240 is the most common, but I have seen up to 240 by 320, and I think there's a lower one, and I want to remember it's something like 132, something along those lines by 240. So similar-ish, but they're configurable. And then we can actually set our color mode, and that's the number. It's basically the variation we have for each pixel, how much control we have. And in this case, this display, we're supporting up to 16-bit per pixel today. So this is going to give us control of our display. Lots of fun.
Yeah, I love how graphics library is so display agnostic. So just instantiating your display regardless of what it is, just setting that and throwing that into a graphics library, and then you're ready to start just drawing shapes and text. It's something that I haven't seen before, so it's pretty cool.
Absolutely. So thank you for that. That's perfect. And so I'll show you is on the display object. So our display class, there's a couple of methods. We've got draw pixels. We can specify a position on the display and do it. I mean, it's actually draw a buffer. I showed you that buffer object above. We'll come back to that. But we actually can pass in a structured buffer of image data. But notice here, there's not a lot else. There's fill and there's clear and a couple of other little kind of handy, convenience methods like invert pixels. But there's not draw a circle, draw text, draw primitives. And that's where the graphics library, that's where micrographics comes in. And exactly what Jorge said, we're going to instantiate our graphics library object, our instance, but notice what we do, we pass the display in. And that's because all of our display drivers today implement a base class of type display base. This will shift, so fair warning, we will shift this to an interface, and a future version will be mostly transparent to you using this, because again, we'll change the constructor for the graphics library, and this will implement it, but some possible breaking changes coming. But the beautiful thing here is all of our pixel-based displays, everything from high-res color to arrays of LEDs, all implement that contract, that base class today. So they can all be passed in the graphics library. And then where graphics library is really fun is, well, that's what gives us the control to do the fun things. So notice here I'm gonna say graphics. And then here is where the fun stuff comes in. So I'm going to here, draw a buffer, draw a circle quadrant, draw lines, rectangles, paths, etc. And you'll notice this API, if you've been around with us for a while, this API is constantly evolving. Path support came in, I want to say V5.2 or 5.3, and you're gonna see these APIs evolve and mature. And what's beautiful about this and this abstraction here is when we move to something like hardware accelerated support as well, these APIs will be consistent. And so you only have to learn one API surface, you don't care which display you're using, and you've got this really nice surface. So with that in mind, let's see how we actually put it into action. So we've got lots of fun things here, and I wanted to switch over to, I'm going to start with draw background. This is a really nice example of using these displays. So very common thing to do is clear out what's on screen. Now every driver has basically an off-screen buffer. We're going to write to that buffer, and then we're going to send it over to the display to represent it. So for graphics, we're going to say clear and blow it out. Now in this case, we can actually pass in a color object, and this will then write that full color to that background buffer. This is really fun. So for B6, you probably saw there's some comments of performance improvements. This is an area where doing full screen clears has been drastically improved. In some previous versions, this would actually take seconds. We're now talking fractions of a second, as it should be. So clear the background color. And then I want to focus here. So again, seeing those primitives, in this case, we're going to draw a circle. We put it in again, standard thing, center X, center Y, a radius. We can give it a color. We can fill that circle. And this is then going to layer up that information on that buffer. Now, this was interesting. This is one thing that I'm really excited about with B6. We've got this draw buffer method. This is new. So again, we're going to pass in a location, an X, a Y, and a buffer. And this is what allows us to our structured data in memory that we can reuse and draw to the screen. And I want to show you where this one comes from. Oh, I will show you this here. For a splash screen, so we draw a background, and then the last thing to do to push that information to the screen is call show on the graphics library. That will then tell the display to update with the buffer, and then beautiful things appear on the screen.
I always forget that the instruction. Even in OpenGL, I would draw and put my scene with drawing shapes, but then why won't it draw? Then it's, of course, you have to do the graphics.show. It'll actually pull the buffer into the display, actually show it. So yeah.
Yeah, and there's a lot of fun conversation to be had there. I won't go into a lot of depth, but with these communication protocols, especially if we've got displays using I2C, it's a relatively slow bus. So you can get good frame rates, but you're not going to get 120 frames per second. And so you want to be intentional, but when you're pushing data over that bus, so this gives you control over when you update the display. We can also do things where we can work on that off-screen buffer and then do partial screen updates. So if we know that parts of the screen haven't changed, when we call show, in this case here, we're calling show with no parameters, but there's also an overload where we can say, hey, we can update either by XY width and height, if I remember correctly, XY left and top and bottom. Sorry, left, right, top and bottom, or pass in a rect. And that's going to tell the display to only update part of the screen. And again, back to sending that data over the bus. In that case, we'll send behind the scenes, we'll send a command to the display saying, hey, we're going to update this part of the screen and then only send that data, which means faster update times for doing partial screen updates. Now let's talk a little bit about that logo, that draw buffer. This is a fun thing here. So I'm going to zip on down here. Now, some of you may have seen this previously. We've got a little lightweight NuGet package that we use to load JPEG data. Let me see if I can find it here. It should be in the packages. Beautiful. Simple JPEG decoder, really lightweight, really simple JPEG decoder. Now, previous versions of Meadow Foundation, you would be pulling that data out into a byte array. You'd be iterating over that byte array and manually updating pixels. Little bit of work. This has gotten a lot easier. Let's scroll down. So now we've got a load JPEG method. This is a convenience method in this code. And it calls another convenience method called load resource. This allows us to load embedded assemblies. And so load resource gets the execute assembly and then gets the resource name based on the project name, Wilderness Labs Klima Meadow Hack Kit up there. Then we pass in the file name. In this case, we're using a file called meadow.jpg that is an embedded resource in our project over here.
Awesome.
Yeah. So lots of fun. And so with that, let me just zip on over here. So a little bit of work, we grab the stream and we grab the bytes out of that. But now what we've got is the JPEG data. So then we need to decode it. So we grab that JPEG data, we run it through the decoder. But now what do we do with that? And that's the fun thing. So now we can create a buffer. In this case, it's a 24-bit buffer, 888. So that's 8 bits for red, 8 bits for green, 8 bits for blue per pixel. And we instantiate this buffer. We tell it the width and the height of the buffer. And then we pass in the data. That comes back from that JPEG decoder, that simple JPEG decoder. Now we have an in-memory representation of that image. You know, you might be thinking on other platforms, yeah, we've got really robust graphics libraries, maybe doing 3D gaming. Yeah, this is simple stuff. But for an IoT lightweight platform, this is a really nice convenience. We're not bloating up our application, but we're making it really easy to manage these type of buffers. And then if we go back to our draw background method, notice here we call graphics draw buffer, give it a location, pass in the buffer data, and it draws. And I'm going to mention one more thing quickly here as well. One thing that's quite fun about this, if you remember when we instantiated our display, we instantiated our display as a 16-bit per pixel display. I won't scroll in the code too much. And so this buffer is actually a 24-bit. So this draw buffer actually hides a little bit of logic where it's actually going to downsample that 24-bit per pixel image to 16-bit on that drawing routine, and it's relatively fast as well. And you will get some performance benefits if you do those conversions manually, so you represent it in a format that's appropriate for the display, but you don't have to worry about that. It will do the conversion for you if there's a mismatch between the display and the logo. And so with that, let me just pull up a quick example. Actually, I can do this the lazy way. And again, we can look at our code here. And again, we can see, once that camera focuses, there we go. There's our we got the full screen clear. We can see the circle. We've got our Wilderness Labs logo here up at the top. And this is how we compose visuals on our displays.
Cool.
Yeah, we go a lot deeper, but I think, we're kind of getting towards the end of time. Anything else you want to mention here, Jorge, before we move on?
Yeah, well, thank you. It's a great project, and all the work, like I've seen how graphics have matured. I built in Hackster a gallery viewer showing little images and showing the old way of like refreshing the whole screen, and then you press a button and it goes to the next image. But that was taking 20-30 seconds to load per image. But now with these massive improvements on B6, all the changes between all these images are full screen refreshes. They're much faster. I haven't quantified them yet, but they are definitely a game changer compared to what we had before.
Yeah, no, it's a lot of fun, and there's more performance we had as well, but it's nice to see B6 had a big bump there. I'm skimming for questions. I see a question of support for other displays. Yeah, there's a request form you can fill in. Come into the Slack channel for Wilderness Labs if there's drivers you're looking for. And again, you can go through the source code. I think I've got this here. There's a ton of example drivers you can look at in terms of implementation. So if you're looking at adding something support for a specific display that we don't have support for today, you can follow those patterns or put in a request, and you'll see the driver surface increase over time.